nation not typically associated with space exploration, but one that's quietly and efficiently making waves in the cosmos. From sending satellites to Mars at a fraction of the cost of a Hollywood blockbuster to developing cutting-edge technology with minimal resources, India is proving that you don't need a billion-dollar budget to achieve space success. But how does a country still grappling with poverty and infrastructural challenges justify these cosmic ambitions? And what does India's foray into space mean for the global space race? Let's dive deep into the fascinating and frugal world of India's space program. Welcome to the AI Lib. India's space story began humbly. In 1980, when India launched its first satellite, Rohini, into orbit, it wasn't aiming to become a space powerhouse. Instead, the mission was clear: leverage space technology to address pressing domestic issues, be it telecommunications, meteorology, or national security. Unlike the United States or the Soviet Union, whose space programs were driven by a race for dominance and prestige, India's goals were pragmatic and focused on improving the lives of its citizens. This practical approach wasn't just a matter of necessity, but a strategic choice. India, at the time, was still developing its technological infrastructure and lacked the financial resources to engage in the kind of space exploration that the superpowers were pursuing. But what it lacked in resources, India made up for in ingenuity and determination. The Indian Space Research Organization, ISRO, was tasked with creating an indigenous space program that could serve the country's needs without relying on foreign technology or expertise. ISRO's early efforts were marked by a focus on building the basic capabilities required for space exploration. This included developing indigenous satellites, launch vehicles, and ground infrastructure. The goal was to achieve self-reliance in space technology, ensuring that India could deploy and manage its own satellites without external assistance. This focus on technological independence laid the foundation for what would become one of the world's most cost-effective space programs. As the 1980s and 1990s progressed, ISRO's capabilities grew steadily. The development of the Polar Satellite Launch Vehicle, PSLV, in the early 1990s marked a significant milestone. The PSLV was not just a technological achievement, but a symbol of India's growing confidence in its space capabilities. Over the years, the PSLV became a reliable and versatile workhorse, capable of launching a wide range of satellites into orbit. This reliability, combined with the cost-effectiveness of ISRO's operations, allowed India to carve out a niche in the global space industry. India's early space missions were all about practicality and meeting domestic needs. For example, the INSAT series of satellites, launched throughout the 1980s and 1990s, played a crucial role in improving telecommunications, broadcasting, and weather forecasting in India. These satellites brought about significant improvements in these sectors, directly impacting the lives of millions of Indians. This focus on practical applications of space technology became a hallmark of India's space program. However, as ISRO's capabilities grew, so did its ambitions. By the early 2000s, India began to look beyond its borders, both literally and figuratively. The success of the PSLV program opened up new possibilities for India in the global space market. What started as a purely national endeavor began to evolve into a program with international aspirations. ISRO's ability to launch satellites at a fraction of the cost of its competitors made it an attractive option for countries and companies around the world. This shift from a focus on national needs to a broader global vision marked the beginning of a new era for India's space program. It was no longer just about technological independence. It was about positioning India as a global leader in space technology. This transformation wasn't just about changing the way ISRO operated. It was about redefining India's role in the global space community. And as we'll see, this shift had far-reaching implications for both India and the world. When you think of space exploration, what comes to mind? Astronauts floating in zero gravity, billion-dollar missions to Mars, and state-of-the-art technology that seems straight out of a science fiction novel? That's the image most people have, and for a good reason. Space exploration has traditionally been the domain of the world's wealthiest nations, with NASA, the European Space Agency, and Roscosmos leading the charge. But India has turned this narrative on its head by demonstrating that you don't need a limitless budget to achieve remarkable things in space. India's space program is a masterclass in cost-effectiveness. Take the Mars Orbiter mission, MOM, also known as Mangalyaan, as a prime example. Launched in 2013, Mangalyaan was India's first interplanetary mission, and it made headlines worldwide, not just because it reached Mars, but because it did so at an astonishingly low cost of just $74 million. To put that into perspective, that's less than what it cost to make the Hollywood blockbuster The Martian, a movie about a fictional mission to Mars. The contrast is even starker when compared to NASA's Mars satellite Maven, which had a price tag of $651 million. So, how does India do it? The answer lies in what ISRO calls frugal engineering. This approach is all about making the most of limited resources, reusing existing technologies, and keeping operations lean and efficient. For instance, ISRO engineers are known for their ability to repurpose technologies developed for one mission and apply them to another, thus saving both time and money. This practice of reusing and adapting technology has become a hallmark of India's space program. Moreover, ISRO's cost-saving strategies extend beyond just the engineering process. The organization has also streamlined its project management and operational procedures to cut down on unnecessary expenses. For example, ISRO missions are known for their relatively small teams and shorter project timelines compared to those of other space agencies. This lean approach not only reduces costs, but also allows ISRO to be more agile and responsive to new challenges and opportunities. But frugality doesn't mean compromising on quality. In fact, ISRO's meticulous attention to detail and rigorous testing procedures ensure that its missions are both reliable and successful. The PSLV, for example, has become one of the most reliable launch vehicles in the world, with a track record of over 50 successful launches. This combination of cost-effectiveness and reliability has made ISRO the go-to option for many countries and private companies looking to launch satellites on a budget. However, as impressive as India's achievements in frugal engineering are, there are also limitations to this approach. While ISRO's ability to deliver high-quality space missions at low costs has earned it global recognition, it has also raised questions about sustainability. Can India continue to push the boundaries of space exploration while keeping costs low? And is it possible to compete with emerging space giants like SpaceX, which are driving down costs even further with innovations like reusable rockets? These are crucial questions as India looks to the future of its space program. The success of Mangalyaan and other low-cost missions has proven that frugality can work, but there's also a recognition that staying competitive on the global stage will require more than just tight budgets. It will require new technologies, greater investments in research and development, and a willingness to take on more ambitious and potentially more expensive projects. This balancing act between cost and ambition is one of the defining challenges for ISRO as it enters a new phase of its journey. While the organization's cost-effective approach has served it well so far, the rapidly changing landscape of the global space industry means that ISRO will need to innovate and adapt if it wants to maintain its position as a leader in space technology. And as we'll explore in the next sections, this challenge is compounded by the increasing involvement of the private sector and the changing role of the government in India's space program. India's space program didn't emerge in a vacuum. It has always been closely tied to government policy and national priorities. In fact, ISRO itself was founded as part of a broader vision to use science and technology to drive national development. Over the decades, successive Indian governments have shaped the direction and priorities of the space program, often using it as a tool for both domestic development and international diplomacy. Under Prime Minister Narendra Modi, India's space ambitions have taken on a new dimension. Modi has positioned space exploration as a strategic asset, both economically and geopolitically. This is a significant shift from the earlier focus on purely practical applications of space technology. While the goal of using space to address domestic challenges remains, there is now a parallel emphasis on using space to enhance India's global standing and influence. One of the most visible manifestations of this shift is India's growing involvement in high-profile space missions. The Chandrayaan-2 mission, for example, aimed to land a rover on the moon, while the Gaganyaan mission seeks to send Indian astronauts into space for the first time. These missions are not just about scientific exploration. They are also about demonstrating India's technological capabilities to the world. Modi's government has also been instrumental in opening up India's space sector to private players, recognizing that the future of space exploration will likely be driven by the private sector rather than the government alone. This policy shift is in line with global trends, where private companies like SpaceX and Blue Origin are leading the charge in space innovation. By encouraging private investment in space technology, the government aims to boost innovation, reduce costs, and create new economic opportunities. However, this move to involve the private sector is not without its challenges. The Indian space industry has traditionally been dominated by ISRO, and transitioning to a more open and competitive market will require significant changes in both policy and mindset. There are also concerns about how well the private sector will be able to handle the risks and uncertainties associated with space exploration. While private companies have the potential to bring in new ideas and capital, they also need to be supported by strong regulatory frameworks and government oversight to ensure that their activities align with national interests. Moreover, the government's strategic vision for space goes beyond just economic and technological goals. Modi has consistently emphasized the importance of space as a tool for national security. In 2019, India demonstrated its anti-satellite missile capability, becoming one of the few countries in the world with this technology. This move was seen as a signal of India's growing military capabilities and its determination to protect its interests in space. At the same time, India's space policy also reflects a commitment to international cooperation and peaceful uses of space. ISRO has a long history of collaborating with other space agencies, and India is a signatory to several international treaties governing the use of space. Balancing these dual roles of being a space power and a responsible global player will be crucial as India navigates the complexities of the modern space landscape. One of the most significant transformations in India's space program in recent years has been the increasing involvement of the private sector. This shift is part of a broader global trend where private companies are playing an increasingly important role in space exploration and technology development. In India, this change has been driven by a combination of factors, including government policy, technological advancements, and the growing demand for commercial space services. Historically, ISRO has been the dominant player in India's space industry, responsible for everything from satellite launches to mission planning and execution. However, as the global space industry has evolved, it has become clear that no single organization, no matter how capable, can meet the growing demands of the space sector on its own. Recognizing this, the Indian government has taken steps to open up the space industry to private players, creating new opportunities for innovation, investment, and collaboration. This policy shift has led to the emergence of a new generation of Indian space startups that are bringing fresh ideas and approaches to the industry. One of the most notable examples is Pixel, a Bangalore-based startup that is developing a constellation of hyperspectral imaging satellites. These satellites will provide unprecedented levels of detail about the Earth's surface, enabling applications ranging from agriculture to environmental monitoring. Pixel represents the new breed of space companies that are not just suppliers to ISRO, but are also innovating independently and competing on the global stage. The government's decision to involve the private sector in space exploration is not just about fostering innovation. It's also about economic strategy. The global space industry is expected to reach over $1 trillion in the coming decades, and India is positioning itself to capture a significant share of this market. By encouraging private investment in space technology, the government aims to create new economic opportunities, generate jobs, and drive technological advancements that can benefit other sectors of the economy. However, the transition from a government-dominated space industry to one that includes significant private sector involvement is not without its challenges. For one, there is the issue of regulatory frameworks. The Indian government has recognized the need for a robust regulatory environment to oversee private space activities, and steps are being taken to establish independent bodies that can regulate and facilitate private sector participation. This is crucial for ensuring that private companies operate in a way that aligns with national interests and international norms. Another challenge is the question of collaboration versus competition between ISRO and private companies. While there is potential for significant collaboration, such as private companies providing launch services for ISRO satellites or developing technologies that can be used in ISRO missions, there is also the risk of competition. For instance, as private companies develop their own launch vehicles or satellite constellations, they may begin to compete directly with ISRO for both domestic and international contracts. Managing this dynamic will be key to ensuring that both ISRO and the private sector can thrive and contribute to India's space ambitions. Moreover, the private sector's involvement in space raises important questions about the future direction of India's space program. Traditionally, ISRO's missions have been driven by national priorities, such as improving telecommunications, enhancing national security, or conducting scientific research. As private companies become more involved, there is a risk that commercial considerations could begin to overshadow these national priorities. Ensuring that India's space program continues to serve the country's broader interests, rather than just the profit motives of private companies, will be a delicate balancing act. India's space program is a reflection of the country's unique approach to innovation, one that is deeply rooted in pragmatism and driven by necessity. Unlike other spacefaring nations that have historically focused on ambitious, high-cost missions designed to push the boundaries of human knowledge, India's space efforts have been primarily directed towards solving practical problems here on Earth. This focus on utility over grandeur has not only set India apart, but has also allowed it to carve out a niche for itself in the global space community. From the very beginning, ISRO's missions have been designed with the specific needs of India's population in mind. The Indian National Satellite System, INSAT, for example, has played a critical role in transforming the country's telecommunications landscape. Before INSAT, vast regions of India lacked reliable communication services, particularly in rural and remote areas. By providing a robust platform for telecommunication, broadcasting, and weather forecasting, INSAT helped bridge the digital divide, connecting millions of Indians to the rest of the world. Similarly, the Indian Remote Sensing (IRS) satellites have been instrumental in supporting agriculture, forestry, land use planning, and disaster management. In a country where agriculture is a significant part of the economy, the ability to monitor crop health, manage water resources, and predict natural disasters is invaluable. The data provided by these satellites has enabled more informed decision-making, leading to increased agricultural productivity and better disaster preparedness. This emphasis on practical applications is not just about meeting immediate needs. It is also a strategic choice that reflects India's broader development goals. By focusing on missions that deliver tangible benefits, ISRO has been able to justify its budget and maintain public support, even in a country where many people still live in poverty. The idea is simple. Space technology should directly contribute to the nation's development, improving the lives of its citizens in concrete ways. However, as India's space capabilities have grown, so too have its ambitions. The Chandrayaan and Mangalyaan missions marked a significant shift in India's space program, signaling a move toward more exploratory and scientifically driven missions. Chandrayaan-1, India's first mission to the Moon, not only successfully mapped the lunar surface, but also made the groundbreaking discovery of water molecules on the Moon, an achievement that placed India firmly on the global space map. Mangalyaan, the Mars orbiter mission, further demonstrated India's ability to execute complex interplanetary missions at a fraction of the cost typically associated with such endeavors. The success of these missions has not only boosted national pride, but also inspired a new generation of scientists, engineers, and entrepreneurs who see space as a viable and exciting field of study and work. Yet, even as India reaches for the stars, it has not lost sight of its original mission. The upcoming Gaganyaan mission, which aims to send Indian astronauts into space, is not just about showcasing technological prowess. It is also about developing the capabilities needed for long-term human spaceflight, which could have far-reaching implications for India's future in space exploration. The mission is part of a broader strategy to position India as a leader in space technology, one that can compete with the best in the world while still addressing the needs of its people. But this unique approach also raises questions about the future direction of India's space program. As the country takes on more ambitious missions, will it continue to prioritize practical applications, or will it shift toward more purely exploratory endeavors? And as private companies become more involved, how will they influence the balance between commercial interests and national goals? These are questions that India will need to address as it navigates the complexities of space exploration in the 21st century. Ultimately, what sets India apart is not just its cost-effective approach or its focus on practical applications, but its ability to do both while steadily expanding its horizons. By staying true to its roots while embracing new challenges, India has shown that it is possible to pursue a space program that is both ambitious and grounded in reality. A program that not only reaches for the stars, but also brings the benefits of space technology back down to Earth. Looking to the future, India's space program is poised at a critical juncture. The country has set its sights on an ambitious array of goals, including missions to explore the moon's south pole, establish a space station, and even send astronauts into space. These plans are part of a broader vision to position India as a global leader in space technology, a vision that will require not only technological innovation, but also strategic foresight and international collaboration. One of the key components of India's future space ambitions is the development of a reusable launch vehicle, similar to SpaceX's Falcon 9. This project, known as the Reusable Launch Vehicle Technology Demonstrator, RLVTD, aims to significantly reduce the cost of launching satellites by allowing the same vehicle to be used multiple times. The successful development and deployment of the RLVTD would represent a major leap forward for India's space program, enabling it to compete more effectively in the global market for commercial satellite launches. In addition to reusable launch vehicles, ISRO is also focusing on developing more advanced satellite technologies. This includes next-generation communication satellites that will provide faster and more reliable internet connectivity, as well as Earth observation satellites that will offer higher resolution imagery for a wide range of applications, from agriculture to disaster management. These advancements are not just about keeping pace with global developments. They are also about ensuring that India remains at the forefront of space technology and continues to meet the evolving needs of its population. Another major milestone on the horizon is the Gaganyaan mission, which aims to send Indian astronauts, or Vyomanauts, into space. Scheduled for the near future, this mission will mark India's entry into the exclusive club of countries capable of human spaceflight. The Gaganyaan mission is not just a technical challenge. It is also a symbol of national pride and a demonstration of India's growing capabilities in space exploration. The mission is expected to pave the way for more ambitious human spaceflight missions in the future, including potential collaborations with other space agencies. Beyond individual missions, India is also looking to play a more active role in the international. India's space program has rapidly evolved from a national endeavor focused on practical applications to a significant player on the global stage. This transformation has not only altered the way India is perceived internationally, but has also positioned the country as a formidable competitor in the increasingly crowded and competitive global space industry. However, maintaining and enhancing this competitive edge will require India to navigate a complex landscape of technological innovation, international collaboration, and strategic policymaking. One of the key factors contributing to India's competitiveness is its ability to offer cost-effective solutions without compromising on quality. The global space industry, which includes satellite launches, space exploration, and space-based services, is a multi-billion-dollar market. Countries and companies alike are constantly seeking ways to reduce costs while maximizing the effectiveness of their space missions. This is where ISRO's expertise in frugal engineering becomes a major advantage. India has built a reputation as a reliable and affordable partner for space missions, particularly for countries and organizations that need to launch satellites but lack the resources to develop their own space programs. The Polar Satellite Launch Vehicle, PSLV, has been at the forefront of this strategy. Since its first successful launch in 1994, the PSLV has become one of the most sought-after launch vehicles in the world. It is known for its versatility, reliability, and, importantly, its cost-effectiveness. Over the years, ISRO has launched hundreds of satellites for customers around the globe, from small, developing nations to major space agencies. This has not only brought in significant revenue for India, but has also established ISRO as a key player in the global satellite launch market. However, the competitive landscape is changing rapidly, with new players entering the fray and existing ones ramping up their capabilities. Companies like SpaceX have revolutionized the industry with innovations such as reusable rockets, which have dramatically reduced the cost of launching payloads into space. SpaceX's Falcon 9, for example, offers a lower cost per kilogram to orbit than many of its competitors, including ISRO. This has prompted ISRO to rethink its strategies and explore new technologies that can help it remain competitive. One such technology is the development of a reusable launch vehicle, which ISRO has been working on through its Reusable Launch Vehicle Technology Demonstrator, RLVD program. The successful implementation of reusable technology would allow ISRO to significantly lower its launch costs, making it even more competitive in the global market. However, developing such technology is a complex and resource-intensive process, and ISRO will need to secure adequate funding and support to bring it to fruition. In addition to launch services, India is also positioning itself as a leader in space-based services and applications. The country's expertise in remote sensing, communication satellites, and navigation systems offers significant opportunities for growth in areas such as agriculture, disaster management, urban planning, and national security. For example, the Indian Regional Navigation Satellite System, IRNSS, also known as NAV-IC, is being developed as an independent alternative to GPS, offering precise positioning data that is critical for both civilian and military applications. India's space program has had a profound impact on national development, demonstrating that space technology can be a powerful tool for addressing some of the most pressing challenges facing the country. From improving telecommunications and disaster management to enhancing agricultural productivity and environmental monitoring, ISRO's achievements have contributed significantly to India's socio-economic progress. One of the most notable impacts of India's space program has been in the area of telecommunications. Before the launch of the Indian National Satellite System, INSAT, large parts of India, particularly rural and remote areas, lacked reliable communication services. The introduction of the INSAT series revolutionized telecommunications in the country, providing the infrastructure necessary to connect millions of people to the global communication network. This has had far-reaching effects, from improving access to information and education to enabling better healthcare services through telemedicine. In addition to telecommunications, ISRO's remote sensing satellites have played a crucial role in supporting India's agricultural sector. Agriculture is the backbone of the Indian economy, and accurate data on crop health, soil moisture, and weather patterns is essential for optimizing agricultural practices. The data provided by India's fleet of remote sensing satellites allows farmers to make informed decisions, leading to increased crop yields, better resource management, and more efficient use of inputs like water and fertilizers. This has not only improved food security in the country, but has also contributed to the livelihoods of millions of farmers. Disaster management is another area where India's space program has made a significant impact. India is prone to a variety of natural disasters, including cyclones, floods, earthquakes, and droughts. The ability to monitor and predict these events in real time is critical for minimizing their impact. ISRO satellites provide vital data that helps in early warning systems, enabling authorities to take preventive measures and manage disasters more effectively. For example, the Indian Meteorological Department, IMD, relies heavily on data from ISRO satellites to track cyclones and issue timely warnings, which have saved countless lives over the years. Environmental monitoring is yet another field where ISRO's contributions have been invaluable. India faces numerous environmental challenges, including deforestation, air and water pollution, and loss of biodiversity. Monitoring these issues from space provides a comprehensive and objective view of environmental changes over time. This data is crucial for policymakers and environmental agencies as they develop strategies to combat these challenges and work towards sustainable development. For instance, satellite imagery is used to monitor deforestation rates in the country's forests, helping authorities to enforce conservation laws and protect vital ecosystems. Beyond these immediate applications, India's space program has also had a broader impact on national development by fostering a culture of innovation and scientific inquiry. ISRO's success has inspired a new generation of scientists, engineers, and entrepreneurs who see space as a viable and exciting field of study and work. This has led to the emergence of a vibrant ecosystem of space startups and research institutions that are pushing the boundaries of what is possible in space technology. These developments are not only advancing India's space capabilities, but are also contributing to the country's broader technological and industrial growth. So, what do you think? Will India's cost-effective approach continue to make waves in the global space race? Or will it need to rethink its strategy to compete with space giants like SpaceX? If you enjoyed this video, please give it a thumbs up, subscribe to the channel, and hit the bell icon so you don't miss any future updates. Check out the videos appearing on your screen right now for more insights and stories from the world of technology. This is the AI Lib. Stay tuned.